Okay, sir. Good evening, students. Today we are going to discuss about 3D geometry and linear inequalities problems on this, and objective questions we are going to discuss now. Here in 3D geometry, it is a continuation in second year. In first year, we are going to discuss some basic points. Based on that, we are going to solve problems. Here, let us start with a problem. Here, note down. First question. The point -2, -3, -4 lies in, their options are given, first octant, third octant, seventh octant, and eighth octant. See here, in two-dimensional geometry, all of you know it's very simple to say the point lies where. Here, in two-dimensional geometry, we take x-axis, positive x-axis, negative x-axis, and positive axis and negative axis. Based on that, we say in first quadrant, that is plus plus, in second quadrant, minus plus, third quadrant, minus minus, and fourth quadrant, plus minus. Easily we can say that point lies in which quadrant in two-dimensional geometry. In three-dimensional geometry also, easily we can say the point lies in which octant. There are 8 octants we get. Observe here how to decide the point lies in which octant. Very simple. Here, let us take this plus plus. This set once again I prepare plus plus and minus plus and minus minus and plus minus, one set. Here one more set I am going to write here as it is, plus plus and minus plus, minus minus and plus minus. Why I am writing these two sets? Very simple. Here I take one example I prepared with this. Here I assume this is, if I remove this one, it is 4 quadrants, first, second, third, fourth. Now this is positive z-axis, this one is positive z-axis, this is positive z-axis, and besides that one more axis, that is negative z-axis. This is positive z-axis, and beside this negative z-axis. For that positive z-axis, I take here this one more coordinate, that is z coordinate, as plus 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 plus. Why plus here? Positive z-axis. For positive z-axis, here all plus, and one more set I have written here. I am going to write for negative z-axis minus 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 minus. Now observe this. Here first, second, third, fourth, here fifth, sixth, seventh, and eighth. Based on these signs, we decide it lies in which octant. Observe here, the point in this all three are negative, that is minus minus minus. It lies in which octant? Seventh octant. Easily we decide it is seventh octant. It is very simple. We prepare one set plus plus, the same set in two-dimensional geometry, the same set we take. Here 4 signs for plus, 4 signs for minus, 4 signs for positive z-axis, 4 signs for negative z-axis. Based on that, we decide it is 7th octant. Based on this point, we can say the point lies in which octant. Whatever the point is given, based on this we decide. Note. Next. Next, we know distance formula. Based on that simple question, we are solving NCERT exemplar questions. The distance of the point, 345 from the origin. What the distance from this point to origin? Here, let us recollect distance formula. Distance formula we know root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. If 2 points we treat x1, y1, z1 and x2, y2, z2, we take this as distance formula. Here, I take this distance formula here, PQ, one point P, 3, 4, 5, and another point origin, 0, 0, 0. That is OP, O is origin, P is that given point. Distance formula, here x1, y1, z1, origin we treat as 0, 0, 0. Here, x1, y1, z1, x2, y2, z2. x2 minus x1, that is 0 minus 3 whole square plus y2 minus y1 whole square, 0 minus 4 whole square, 0 minus 5 whole square. Here minus 3 square, that is plus 9, minus 4 square 16 and minus 5 square 25. 9 plus 16 plus 25, root 50 is distance from point to origin. Here in first year we have discussing only simple concepts. Already in theory we discussed about distance formula, section formula. Here distance from point to origin. Simple question. For next one. Options I have not written. Simple one. Next, the distance of a point P 3, 4, 5 from the YZ plane here. First option 3 units, second option 4 units, third option 5 units, here fourth option 6 units. The distance of the point from the point 3, 4, 5 from the YZ plane. Here, just now we discussed this, the plane. The board is 2D plane. Here, the 3D plane we are going to assume here. Let us recollect this. Just imagine here 3D we are going to use here. The diagrammatic approach, just see with a rough diagram. I am preparing coordinate axis, that is x-axis, y-axis. In 3D, three-dimensional geometry, one more axis, that is z-axis. We call it is space. Here, observe this, x-axis, y-axis and z-axis. Here, it is x, o, y plane, xy plane. Here, y, o, z, it is yz plane. Z, o, x, it is z, o, x, that is zx plane. We call it is xy plane. It is yz plane. It is zx plane. Here in question it is given the distance of the point 3, 4, 5 from the YZ plane. What is the distance? From this point to YZ plane, what is the distance? Also here, if I assume a point in space that is 3, 4, 5, it is in first octet. From this, if I drop a point on YZ plane. On YZ plane, very important point, on YZ plane, X coordinate is 0. Here, if I prepare a foot of the perpendicular on this YZ plane, that is X coordinate is 0. On YZ plane, X is missing, X coordinate is 0. That is, I assume this point as Q. In YZ plane, X coordinate is 0, 0. And YZ is similar to this 4, 5. This is a foot of the perpendicular from this point to YZ plane. Now, this P to Q, this is our requirement from P point to Q. What is this distance? This dotted line distance. PQ is equal to, let us prepare a distance formula just now. We recollected what is distance formula? Very simple. X2 minus X1 whole square. X1, Y1, Z1, X2, Y2, Z2. Apply this formula. Here 0 minus 3 whole square plus 4 minus 4 whole square plus 5 minus 5 whole square. What we get here? Minus 3 square, 9 plus 0 plus 0. That is root 9. Root 9 value here 3. From this point to YZ plane, what is the distance? 3. From this question, two more questions we are going to solve here. From this point to YZ plane, 3, we are getting distance. Similarly, from this point to XZ plane and YZ plane, XY plane also, we can prepare in the same manner. Note down. For XY plane, if it is mentioned in XY plane, Z coordinate is 0. In XZ plane, Y coordinate is 0. Next question. Next. What is the length of the foot of the perpendicular drawn from the point 3, 4, 5 on y-axis? Here, in previous problem, we prepared distance from a point to YZ plane. What the distance? Here, similar question, there on YZ plane, here from this point on y-axis. Once again, I take this rough diagram, x-axis, y-axis and z-axis. Here the point 3, 4, 5. From this point, in question it is mentioned point P on y-axis. I take y-axis here. From this point, if I drop a foot of the perpendicular on y-axis, we know on y-axis x coordinate is 0 and z coordinate is 0. Here what it becomes here, the point on y-axis, here x coordinate is 0 and only y distance and z coordinate distance also 0. I treat this point as q. In previous problem, yz plane x coordinate 0. Here on y-axis, x coordinate and z coordinate 0 only, that is y distance. Here these 2 points distance here, length of the foot of the perpendicular. This length we are going to find, that is PQ, from P point to Q point. Once again distance formula, root over here x1 y1 z1 x2 y2 z2. Here x2 minus x1 whole square, 0 minus 3 whole square plus 4 minus 4 whole square plus 0 minus 5 whole square. Here minus 3 square 9 and 4 minus 4 0 and 0 minus 5 whole square 25. This is 34 from P point to y axis. The length is 34. Next question. If the distance between the points, if the distance between the points A01 and 012 is root 27, then value of A, in theory we have learned distance formula, section formula. Based on that we are solving questions here. Options is given 5 plus or minus 5 minus 5 and none. Here the distance between points, here 2 points are given, A01 and 012. This distance is root 27. Then what is the unknown value? A. Here these 2 points, I name these points as first point A01 and second point as B012. The distance between these points A to B, this distance in question it is given root 27. Here AB is equal to distance root 27. Apply distance formula. Here if you apply distance formula we get root. For avoiding this root, make squaring on both sides. That is AB square is equal to 27. Without root apply formula. Here 0 minus A whole square plus and 1 minus 0 whole square plus 2 minus 1 whole square is equal to 27. Here minus A whole square, A square plus 1 square plus 1 square, 2 minus 1, 1 square is equal to 27. A square plus 2 is equal to 27. Here A square is equal to 27 minus 2, 25. A is equal to plus or minus 5. Here distance is always positive, but the value of A may be positive, may be negative, plus or minus 5. Here that is second option, plus or minus 5. Next question. Next question. X-axis is intersection of the planes. Which planes intersection is x-axis? It's a very simple one. Here, xy, xz. It is a combination xy plane and xz plane. Here, xy and xz. X is common. Here, x-axis is intersection of xy and xz plane. Similarly, we can say about y-axis. Y-axis also we can say it is intersection of xy and yz. Here, z-axis also we can say in the same manner. xy and xz, x is common, that is first option. xy and xz. It is intersection of these planes, xy and xz. One more question. Equation of y-axis is considered as options x is equal to 0, y is equal to 0. Y is equal to 0 and z is equal to 0. Z is equal to 0, x is equal to 0. None. Just now we discussed about this point. Equation of y-axis. Equation of y-axis, on y-axis x coordinate and z coordinate is 0. Here on y-axis, here x coordinate and z coordinate is 0. X is equal to 0 and z is equal to 0. Similarly, equation of x-axis. X-axis, here y is equal to 0, z is equal to. Similarly, we can prepare equation of z-axis also. Here NCRT exemplar questions we are solving based on basic points. Next question. A plane is parallel to YZ plane. So it is perpendicular to x-axis, y-axis, z-axis. Here also we are going to recollect that point. Earlierly, we have discussed that a plane is parallel to YZ plane. Roughly, we collect once again the space x-axis, y-axis, and z-axis. A plane is parallel to YZ plane. Here we know YZ plane. It is YZ plane YOZ. It is YZ plane complete. It is YZ plane. Here XOY. It is XOY plane. That is XY plane. Here XOZ. It is XZ plane. Here YZ plane is perpendicular to this plane is perpendicular to which axis? X axis. YZ plane is perpendicular to X axis. Here the parallel to YZ plane is perpendicular to X axis. If I take a parallel to YZ plane, it is also perpendicular to X axis. Similarly, XY plane is perpendicular to which axis? Z axis. ZOX, that is XZ plane, is perpendicular to which axis? Y axis. Say here, the plane is parallel to YZ plane. The plane parallel to YZ plane is perpendicular to which axis? Which axis here? Here, which axis? YZ plane perpendicular here, X axis. Parallel plane also perpendicular to X axis. Here, two more questions we can see from this. Here, YZ plane, I take XZ plane and XY plane. Next question. The locus of a point for which y is equal to 0 and z is equal to 0. Y is equal to 0 and z is equal to 0. What is the locus of the point? Here options are given: equation of x-axis, equation of y-axis, equation of z-axis. Just now we discussed this one. Y is equal to 0, z is equal to 0. Both are 0 means it is on x-axis only it is possible. Y is equal to 0, z is equal to 0 is possible only on x-axis. Here x is equal to 0, y is equal to 0 is possible only on z-axis. Here similarly we can prepare one more. Okay. Y is equal to 0, z is equal to 0. It is possible only on x-axis. Next. Next question. Here, if a parallelepiped is formed by the planes drawn through the points 5, 8, 10 and 3, 6, 8 parallel to the coordinate planes, then length of the diagonal of parallelopipe. Here, simple one, I take x-axis, y-axis, z-axis. What it is given, if parallelepiped is formed by the planes drawn through these points 5, 8, 10 and 6, 3, 6, 8 parallel to the coordinate planes, that is coordinate planes means xy, yz and zx. Here roughly I collect this. Here 5, 8, 10 point and 3, 6, 8, 10. This here a parallelepiped, let us assume this point, one point P and one point Q. Length of the diagonal. Here this parallel to YZ plane, parallel to this. Here from this point, if I prepare a parallelepiped parallel to the coordinate planes, we get a rough diagram I collected. Here length of the diagonal. Length of the diagonal means from P point to Q point. Here length of the diagonal gives P point to Q point. Here PQ, these 2 points I assume one point P and one point Q. Here just distance formula x2 minus x1 whole square plus y2 minus y whole square plus z2 minus z1 whole square. Here 5 minus 3 or 3 minus 5 we can take in any way. 3 minus 5 whole square and 6 minus 8 whole square plus 8 minus 10 whole square. Here 3 minus 5 whole square, that is 2 square, minus 2 square, that is 4. Here 6 minus 8 whole square, it is also 4, plus 8 minus 10 whole square, it is also 4. 4 plus 4 plus 4, 12, root 12, that is 4 into 3, 2 root 3 units. 2 root 3 units is the length of the diagonal of this parallelepiped. For this parallelepiped, if I want only length, width and height, if I want length, just distance between these x coordinates gives length, and distance between y coordinates here width, and distance between z coordinates height we get. Here in question it is mentioned that length of the diagonal, here these 2 points 5, 8, 10 and 3, 6, 8. This distance, these 2 point distance gives length of the diagonal. Note down. Next, we'll solve problems on linear inequalities. Here, linear inequalities, in theory, we have learned many properties. Based on that properties, we are going to solve. Here, note down, first question on linear inequalities. Here, like linear inequalities. If x is less than 5, then options are given minus x, see here. In linear inequalities, we have learned properties. X is less than 5. In question, it is given x is less than 5. Then what about if you multiply with minus sign? In options, if you observe all options multiplied with minus sign. Here also I multiply with minus sign. If you multiply with the minus sign, that sign of the inequality is reversed. That is less than 5 becomes greater than minus 5. Here, if you multiply with a minus sign, minus x is greater than minus 5. Which option? That is third option. Next. Given that here I'm not writing options, directly we will solve. Given that x, y and b are real numbers, x is less than y and b is less than 0. Clearly it is mentioned that b is less than 0. Less than 0 means negative. Here, this question from options, x by b is less than y by b. First option, x by b is less than or equal to y by b, and x by b is greater than y by b. X by b is greater than or equal to y by b. Observe here, x is less than y. B is negative value. We are multiplying with, observe this, in options, all options are x by b. Here multiplied with 1 by b. That is x into 1 by b multiplied with negative number. Multiplied with a negative number, that sign of the inequality is reverse. B is less than 0, negative number. Here x is multiplied with 1 by b, that is negative number. That sign of the inequality is reversed. Less than 0 becomes greater than y by b. Here x by b is greater than y by b. Next. If minus 3x plus 17 is less than minus 13, then what about x? Minus 3x plus 17 is less than minus 13. What is the value of x? X lies on what interval? Here, minus 3x less than minus 13. Take this 17 RHS side, that is minus 17. Minus 3x less than minus 13. Here, minus 3x less than minus 13. If I multiply with a negative sign, negative number, that is negative sign, that is minus 1. If I multiply with minus 1, here minus 3x, minus into minus, plus. The sign of the inequality is reverse, greater than. Minus into minus, plus. Here, if I divide with 3, here x is greater than 30 by 3, 10. X is greater than 10. X is greater than 10. What it shows? Greater than 10. That is 10 to infinity. Open bracket. 10 is not included here. Greater than 10. So that 10 to infinity. X lies in this interval. Then only it satisfies. 10 to infinity only satisfies this inequality. Next. If x minus 1, mod x minus 1 greater than 5, then x lies in what limits? X interval. Modulus property. Here, this options I am not writing, just observe this. Mod x minus 5 is greater than 5. We know modulus property. If mod x is greater than a, it implies that x is less than minus a or x is greater than a. Here, this property I'm going to use here. Mod x is greater than a, then x is less than minus a or x is greater than a. Here, complete this x minus 1, I treat as x and 5 as a. Let us apply this property here. What we get? X minus 1 is less than, what is a place here? 5 minus 5, or x minus 1 under mod value. The complete this I treat as x minus 1 greater than a is 5 here. That is x is less than minus 5 plus 1. X is less than minus 4, or x is greater than 5 plus 1. Here x is greater than 6. Here already in set theory we learned about OR. OR means we take union symbol. Here x is less than minus 4. That means minus infinity to minus 4. Minus 4 is not included, so that open bracket. For OR, we take union x is greater than 6. Greater than 6 means here from 6 to infinity. 6 is not included. Greater than 6 to infinity. Open bracket. We take open bracket here, 6 to infinity. We take this in real line. That is minus infinity to plus infinity. Here minus 4 and 6. Here complete this. Minus 4 is not included, so that 6 also not included. Next. Here, if mod x plus 2 is less than or equal to 9, then x lies on what interval? Similar question, there greater than, here less than. Mod x is less than or equal to a. X lies in between a and a. Here, this property I'm going to take here. Mod x is less than a, that x value lies in between minus a and a. Here equality sign is there, so that we are going to take equality. Equality is not there, we'll take only that less than symbol. Observe this, a place here 9. Here I take this property here. What is x place here? X plus 2. X plus 2 is greater than or equal to minus a. Minus a means minus 9. Less than or equal to a, 9. Here we want x limits here, the domain of x. For this I prepare x here, for that I subtract 2 on middle, that is x plus 2 minus 2. Here both sides we need to subtract. Minus 9 minus 2 less than or equal to 9 minus 2. Here minus 11 less than or equal to x less than or equal to 7. Here x limits here minus 11 to 7. Observe this equality sign is there. Minus 11 we need to include, 7 also we need to include. That is closed bracket. X limits minus 11 to 7.
Sir, you can
Sir.
continue next, sir. You can continue next class, sir.
Okay, sir.
All right.
Okay, sir. Thank you, sir.